In probability questions, you end up doing a lot of counting. And we are going to use today a tree diagram to help us count accurately. So in this, imagine if you will, you've got a bag that contains 2 red, 2 blue and 1 green stones. What are all the possible methods to select 2 stones? So this is a compound event, because pulling the first stone out is the first event, and then pulling the second stone is the second event. And tree diagrams are particularly useful in compound events. So, how do you do it? Well, you start off drawing a thing that looks like a tree. So I think of these as time moving to the right. So you start with nothing, and then the first event is pulling a stone out, and you can pull out a blue stone, a red stone, or a red stone, or a blue stone, or a blue stone, or a green stone. And that's the first event. And each of those, if you did it, pulled out a stone over and over and over again, repeatedly, did the experiment many times, you'd expect 1/5 of the times you get the first red one, 1/5 of the time you get the second red one, 1/5 of the time you get the first blue one, 1/5 of the time you get the second blue one, and 1/5 of the time you would get the green one. So then you pull out the second stone. Pulling out the second stone means that you've only got 4 stones left in the bag. You've got red, blue, blue, green, red, blue, blue, green, if you happen to have pulled out a red stone first. If you happen to have pulled out a blue stone first, you've got red, red, blue, green, red, red, blue, green. And if you pulled out the green one first, you've got red, blue, red, blue. So you'll notice that there's a bit of pattern developing. When these 4 and these 4 are the same, and these 4 and these 4 are the same, and this one is different because, and it's all dependent on which colour came out first. So these stones, this is where we actually list out all the members of the sample set. This is the first stone, which is just the same colour as this first stone, and this is the second stone. So you can see you've got red, 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 blue, red, blue, red, green. And because each of these items are equally likely to occur, because they're all equally likely, and there's 20 of them. There's 5 ways to pull the first stone out, and then for each of those 5 there are 4 ways of pulling the second stone out. So you get 20 equally likely outcomes. So the probability of each one of these is 1/20th. And if you go back, so with these patterns here, you can treat these patterns that are the same a little bit more mathematically and use less ink or less pencil lead. You can look at a condensed version. So instead of drawing 5 branches, you say, well, we're really only interested in the colour, so we're going to draw this branch with red, and we're going to say 2/5 of the time you get to here, 2/5 of the time you get to here with a blue stone, and 1/5 of the time you get to here with a green stone. So there's 5 stones, that's why I've got fifths, and there's 2 red, that's why I've got 2, and 2 blue, so that's what this 2 comes from, and then only 1 green, so that's why I've got this 1/5. And then you look at the next one, the next drawing, you've only got 4 stones left in the bag. If you've pulled a red one out already, you've got a red 1/4 of the time, a blue 1/2 of the time, or 2/4 of the time, and green 1/4 of the time. And down here, if you've pulled a blue one out already, you've got red 2/4, 1/4 blue and 1/4 green, and 1/5 down here. You've got no green ones left. You've got 1/2 of them are red and 1/2 of them are blue. And here is the first. This is where we list the outcomes. You've got 3 ways. These are the colour of the first stone, and this is the colour of the second stone. So you'll notice here that we've got red, 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 blue. We've got all the stones in order, and there's only 8 different things in your sample set there. So, whereas over here there was 20 things in your sample set, and it's the same experiment. So what's happening is that over here these are all equally likely, and they're all a probability of 1/20th, but over here they're not equally likely. You've got more chance of getting into this group and this group than you have of getting into this group, because there are 2 ways to get a red one and only 1 way to get a green one. So if we look at red, for instance, we see we've got 2/5 of the time we're going to get the first red and 1/4 of the time we're going to get the second red. If you go back here, looking at red, you've got a red there and a red there. So you've got 2 ways to get a red, 2 out of 20. And if you look over here and you multiply 2/5 by 1/4, you end up with 2/20. It's just using multiplication as repeated addition. Over here you had 1/20 and 1/20, and over here you've got 2/20, which is the same as 1/20 and 1/20, and you get that from multiplying 2/5 by 1/4. You get 2/20. And you can choose any combination that you like. Say green-red, for instance. Green-red, 2/20 of a chance. If you go back over here, green-red, there's one way it can happen, and that's the second way it can happen. So you get 2/20. And that is how we use tree diagrams and counting math and working mathematically to count compound events.